So we're going to solve a couple more equations now given a particular domain. And the first one we've got is sine of 4x equals sine of 2x. Now with this equation, you want to be careful here. We're going to use our compound angle formulas or double angle formulas. They're interchangeable really, but we'll use a double angle formula. It's a bit easier to work with. So what we're going to do is we're going to imagine this is 2x and this is x. Okay, so remember that from our double angle formulas, sine of 2x equals 2 sine x cosine x, like that. Okay, so that means that sine of 4x equals 2 sine of 2x cos of 2x, because all we've done here, whatever that angle is there, you halve it here, or alternatively, whatever that angle is, you double it. So that means, because we know what sine of 4x is, let's rewrite our expression now using this identity here. So we've got sine of 4x is equal to 2 sine of 2x cos of 2x equals, and now let's put in our right side, so sine of 2x. Okay. And it's always good to put like a so there so we know what's going on. So at this point you might be tempted to do a cancellation here of the signs. Okay, divide both sides by sine 2x. Now there's a problem with doing that, and the problem with that is when you're cancelling, remember that what you're doing is this, sine of 2x. Now that's fine, provided that sine of 2x doesn't equal 0, because if it does equal 0, you're going to have the problem that you're dividing by 0. So to avoid that, what we can do, you can either consider sine of 2x equals 0 as a separate case, and then cancel and then solve what you've got left, or what you can do, which is just as easy, is put everything onto one side of the equation, so bring this over, and then we're going to factorise anything that's in common here. And you can see that what's in common in both is that sine of 2x. So we're going to factorise that. The common factor coming out the front, you've got 2 cos of 2x left inside the bracket minus 1 equals 0. So what that means is we've actually got two things that we have to solve here. One, when you've got two things multiplied together that equal 0, either they both equal 0 or one of them equals 0. So we do have the situation that sine of 2x can equal 0. Okay? And the second situation that we have is that 2 cosine of 2x minus 1 equals 0, which implies that cos of 2x equals a half. So we've got two different situations. We're going to need to look at both of those. And remember that we're interested in the same domain for each. So for 0 to 2 pi. Okay, so let's consider them one at a time. The first one, we're going to consider 1. And we've got sine of 2x equals 0. So what that means for us, and we'll think about this here, is this angle 2x, we need to think about what it's going to be maximum minimum at these values here. So when x equals 0, we've got 2x equals 0, and when x equals 2 pi, we've got 2x equals 2 times 2 pi, which equals 4 pi. So for sine of 2x equals 0, we're going to consider that for 2x in between 0 and 4 pi. Okay. The other way of doing that would be also just to take this domain here and multiply both sides by 2 to get the 2x. So 0 to 4 pi. So solving this equation now, we've got 2x equals, where does sine of an angle equal 0? Well, on the unit circle, that's anywhere where you're here, where you're horizontal. So that would be 0, pi, 2 pi, 3 pi, and 4 pi. We start and end at 0 and 4 pi. And so therefore x equals, divide both sides by 2, pi on 2, pi, 3 pi on 2, and 2 pi. So there are answers for part 1. We also need to consider part 2. So I'll just get rid of this part here. So for part 2 now, we've got cos of 2x equals a half, and just as we did before, we're going to consider only for 2x in that region of 0 to 4 pi. Okay, so when does cos of something equal a half? Well, we know from our triangle that cos of pi on 3 equals a half. So And here it's positive a half as well, so that would be pi on 3. And for cos to be positive, it needs to be in quadrant 1 or quadrant 4. So we'll start solving. So we've got 2x equals, and we know the first solution for this, remember that when cos of x equals a half is going to be pi on 3. So we've got 2x equals pi on 3. The next solution is going to be all the way around here, which is negative pi on 3, and we should really think about that as being 1 less than 6 pi on 3, so 5 pi on 3. You're then going to add 2 pi to get back to your next answer, 7 pi on 3. Okay. Then going all the way around here, it's going to be another 4 pi, because you took 4 pi to get from here to here, 4 pi on 3. So 4 pi on 3 would be 11 pi on 3. Now remember we need to go to 4 pi. 4 pi is going to be 12 pi on 3. If we add another 2 pi, we're going to go over 4 pi. So that's actually all the solutions we have. And finally, we're going to have x equals, divide everything by 2, so pi on 6, 5 pi on 6, 7 pi on 6, and 11 pi on 6. Therefore, to finish it off, we know that for sine of 4x equals sine of 2x, our solutions, and there's a few of them, are x equals, we put them all together. Now you can put them together in order, it doesn't really matter. I'm just going to put them together in the order that we had here and then this one here. So 0, pi on 2, pi, 3 pi on 2, 2 pi. And if you've got doubles, you don't have to count them twice, but actually in the two lists that we have, nothing doubles up. So we can write all our solutions down. So what we've done there is we've solved this first equation. Remember not to cancel out your signs, okay, or any trig if you're trying to solve an equation with trig, because you do have that situation where that trig can equal 0. And when you're cancelling things, you're dividing by that thing. And if it's equal to 0, you can't divide by it. So it's easier if you factor it out and then consider different cases. So we considered 2 cases, case 1, case 2, found our solutions for those 2 cases, and then gave our full solution.